Thanks for reminding me. Okay, we're live.
Oh, you're good.
Okay, so did everybody get a chance to get through it?
I got through it as far as going
much
through
as
it very well. I don't know.
How about you, Alan? Is he still there? I think we might have lost him.
Oh, uh-oh, he's frozen.
Oh,
hello.
If you can hear us, log off and log back on. You're frozen.
Oh.
I don't know if he's doing
I can hear you.
I wonder if it's your internet connection because you kind of keep cutting in and out.
I can hear us.
You can hear us?
Okay, so we were just asking if you were prepared and got
I can hear you. I have.
Okay, perfect.
Okay.
Okay, so we can just take turns with this then.
Sure.
I can start. Question 3. Which hypothesis involves equality equal? The null, number 1?
I put down the null.
Okay. Did you get the same, Alan?
Can you guys hear me? Can you guys hear me?
You keep cutting in and out.
I can see your text message, yeah.
Okay.
Yeah, so did you get that for number 3?
Dakota, are you there?
Yeah, I'm still here.
That was weird.
Yeah, I guess I'll come back.
So is he texting you? Is he just have a bad connection? What was he saying?
Well, on the chat, he put on group chat. Can you guys see that? And then
yeah,
looks like he's
okay. Try him
back. So if he cuts out, then maybe we can just do group chat for him. Okay, Alan, can you hear us?
Yeah, I can hear you. Can you hear me?
Yeah. What did you get for 3?
I got the null hypothesis.
Awesome. That's it. Okay.
So 4.
Yeah, for question 4, I got null hypothesis.
I said alternative.
Can remember that?
I said it because it says actually observed.
String as a 1.
Okay.
And I read somewhere in the book where it defined it and it used that exact terminology. Let me see if I can find it. My notes are, I didn't do my notes this time.
Gotcha.
Can you hear me?
Okay, it says, in contrast to the null hypothesis, we write the alternative hypothesis. Oh gosh, that's not the part.
When computing the p-value. Let's see, where's my... I had something up here. There's my textbook.
Hypothesis is true, and we want to make it false. And that is when we use alternative.
And I could be wrong, Dakota. I just, for some reason, I underlined that because I read it in the reading.
Okay. Well, we can go ahead and I'll put down alternative hypothesis and that because I can't remember where I saw what I put down. So I have switched it to alternative and we'll see.
Yes, we'll see.
See what happens. Yeah.
Okay.
Question 5. I got for the alternative hypothesis, mu is not equal to 10.
That's what I got as well.
Okay. Did you get that, Alan?
Okay. Do
Is
my
that a yes?
messages.
Oh, there it is. Let's see. The null hypothesis, because is the true one, and we want to make it false. Wait, so you put null hypothesis for which one? Is that for question 4?
For question 4.
You put null. Okay. Well,
Well, we can try null.
sure. Okay, so question 4, we put null.
And 5.
Did you put down mu is not equal to 10?
Yes.
Okay, so we'll do that one then.
Okay, so then 6, I put mu is less than 10.
Yep. Did you get that, Alan?
Yeah.
Okay.
Yes. I messaged you.
Oh, sorry. Okay, yeah, I'm seeing your messages now. Okay, so we will move on to question 7. Is that what we're on?
Yeah, and
Yeah.
I put mu is greater than 10.
Yes, I put mu is greater than 10. Is that what you put down, Alan?
Yeah.
Okay. Okay, very good. Question 8, I put down the p-value is greater than alpha.
Yes, that's what I put. Number 1.
Uh-huh.
Yeah, me too.
Is that what you got, Alan? Let's see.
Sure. Yeah.
So you got that the first answer, Alan, for question 8?
Yeah. No. This thing is so gay.
I'm sorry.
I don't know why you can't hear me. Can you hear me?
Oh, looks like you're calling me now. Hey, Alan.
I can hear you guys.
You can hear us, but we can't hear you.
but-
Okay.
I know.
It's my ear.
Okay, well, I'm going to mute you on here on the screen so that way I can just hear you on this.
Okay.
So, yeah, just talk through the phone and we'll make it work through that.
Yeah, that's much better.
Be better.
Because I said the messages
Because
with the answers, and I think it took you guys long to get the messages
I think it's taking the.
that I'm sending. And now the connection is over for me.
Okay.
Can you hear me?
Yeah, I can hear you. So what question were we on, Stephanie?
We're on 9.
We're on question 9.
We say it was P value is better than alpha, so A.
Yeah, so for question 8, the p-value is greater than alpha. Yep.
And then what did he get on 9?
What did you get for question 9?
I put D.
You
The
put
last one.
the last
D
one?
value is Z.
Okay.
I put B.
I put down B. The p-value is less than alpha.
And that's what I put as well.
Okay. So was there a spot in the book that you saw that answer, Alan?
There was one thing that
The thing
I
that
saw,
I
I think it was the next question or something. But no, but you have to. There was one thing that I was confused about it.
But I don't know.
Let me see if I can find what I'm trying to say. Let's see. I can't really find it. I'll tell you later in a little bit if I find it.
Okay.
So are we going to agree that it's the last one or the second one?
Yeah, which one are we agreeing on, Alan? Did you want to do p-value is less than alpha, or did you want to do p-value is less than z? Because Stephanie and I put down the
Let's go
second.
for the alpha, because I don't know where I think it might be one of the questions later. Like
Okay.
15 or something.
Keep that one in mind, but yeah, go ahead and switch it to p-value is less than alpha. If it's wrong, then we'll switch it over to the other one.
Okay, I have it down.
Okay. So for question 10, I put down the average claim is greater than 1,500.
I put the average claim amount is not equal to 1,500.
Okay. Let's
I
see.
did the same thing as you, Dakota.
What would be the appropriate alternative hypothesis? Let's see. I think for these questions, this is where it's important to understand what an alternative hypothesis actually is. And this is, I don't know if I have this right, because like when you start using null hypothesis and alternative hypothesis, it gets confusing to me. But from what this is what kind of what I think is like the null hypothesis is the claim that has been said in whatever it is you're doing. So it's like if the mean of some set of data is 150, then the null hypothesis is that that claim is true. Is that right?
That's kind of how I understood it, but that's why I picked not equal to, because we have, how do we know that the alternative hypothesis doesn't think it's lower or higher?
Right.
I just thought of it generic as just not equal.
Gotcha.
That's why I picked that one, because how do we know if it's more or less?
Oh, well, it says in the information, it says that they are concerned that the true mean is actually higher than 1,500.
Oh, I misread that. Okay.
Yeah. So if that little tidbit wasn't in there, then it would be the average claim is not equal to it.
Okay. You're probably, I agree with that.
So I think that's the reason why I put that down.
Okay.
Does that sound good, Alan?
So less than, so D?
I put down the, let's see. I put down C. The average claim amount is greater than 1,500. Because right now they believe that it's 1,500, and 1,500 is the null hypothesis.
Oh, because it says they're concerned that the true mean is actually higher than this. Okay.
So if the null hypothesis is rejected, the alternative would be that it's actually higher.
Okay.
So they're asking for the alternative, the HA, and that's why I put that down. So if it's not right, then I mean we've got more opportunities to fix it.
Yeah.
Yeah, so that was the same reason that I chose C.
Awesome.
Because they don't want it to be more than 1,500.
Yeah. Okay. Well, let's go with that for now. Question 11. I put down the average claim amount is equal to 1,500.
So did I.
So, which one do you guys put?
For question 11,
I put D.
you put D. I said the average claim amount is equal to 1,500 because it's asking about the null hypothesis.
Right.
Yeah, or in other words, it's asking about like what they think the claim actually is. And that's the number that they said in that little information bit. So we can try that if you want.
I'm going to write that one down too. Because I feel like the insurance wanted to pay less than 1,500. They don't want it to go more than that.
What are we just saying?
Sorry, what are you saying, Alan?
I'm just saying that I'm going to write that down. So in case it goes wrong, we can try D for the answer.
Okay.
Okay.
Yeah. So yeah, keep that one in mind.
Why don't we have Alan do 12?
Yeah. So Alan, what's your answer for question 12 then?
I have, it is a good assumption and the sample is large.
It is a good assumption since the sample size is large. That's what I got as well.
That's what I put as well.
Yep, sounds good to me.
And then on 13, what theorem or law justifies your answer to the previous question? I said law of large numbers.
Same.
I put down the central limit theorem.
I always get those two.
I
Look at
could
the
be wrong.
definition.
it's 2-1 right now. So
I know, huh?
let's see. It's asking about.
So central limit says you have observed in the simulations that if a sample size is large, the random variable x will appropriately normally distributed. In other words, the sampling distribution of the sample size will be approximately normal if the sample size is sufficiently large.
And that's for what theorem?
Central limit theorem.
Oh, okay. So
And,
it's so the claim is saying the insurance company assumes that the distribution of the sample mean is normal. And so I don't know if I'm reading this right, but I think I am. So if the sample size is sufficiently large, then the distribution is going to be normal.
You're probably right, because as I'm reading the law of large numbers, it states that the sample size is large, then the sample mean will typically be close to population mean.
Right. And I don't think we're talking about population
Right.
mean
So-
right now.
Central limit theorem. Okay, I agree.
Yeah.
I'll take care of
Alan,
that.
are you okay with changing it to central limit theorem?
yeah, I would be confused with those two.
Okay. Yeah. I always have to go back and look at it.
Same.
Okay, so 14 then, which of the following is the test statistic and defined in this as defined in this lesson? And I put Z.
I put Z.
Same.
Yep.
Yeah.
Okay.
Perfect. Okay, question 15. This is where it starts getting a little hairy. It gets a little confusing, but for question 15, I put as the Z-score -0.9.
I had positive 0.9.
Well, let's see. I think I might have written this down. So the Z-score, we're calculating it through the X with the line over it, which is like the mean of the means, kind of. So the observed thing that we're looking at.
So it would be the 150, right?
I put down 144 for that one because
Oh, you're right. You know what? That's what I did. I put those two numbers backwards, so it would be negative.
Gotcha. Yeah, so 150 is the mean. The observed is 144.
So it's 144 taken away from 150, which makes it negative.
Yeah, so -6 divided by 6.666666 whatever 7.
Yeah.
So that makes it -0.899999 whatever.
Yeah.
I have a question. For the standard deviation, which number do you use? Because I know we use the sample of 36.
Standard deviation is $40. That's what it says on here.
Oh, okay.
Yeah, so at the top with the information section, standard deviation of 40. The sample size is going to be 36. So my equation was 144 minus 150 divided by 40 divided by the square root of 36. And
Yeah.
that's where I got my number. It says round to 3 decimal places, but it comes out to -0.900 if you really want to tally it all the way over to 3 decimal places. So hopefully that's right. Okay.
So then in 16, don't we just take the Z-score and put it into the applet?
I think so, yeah. And then to find the p-value, you look at like the little areas to the left and the right.
Right.
Yeah.
And I got 0.3681.
Yeah, that's what I got.
Okay.
And it says round to 3 decimal places, so
0.368.
yeah, 0.368.
Oh,
Awesome. Okay, so for question 17, if that's right, I put down fail to reject the null hypothesis.
okay, so this is where I get confused. I didn't answer that one because what, I mean, I've got the numbers, but I guess I'm having trouble understanding what the numbers mean.
Okay.
Is it 0.90 comparing to the 150?
Let me see if I can find it. I've got it in
I
my.
can explain.
Yeah, go ahead and explain that.
Can you hear me, Stephanie?
Yeah, I can hear you.
Okay. So based on what the reading and the videos, it says that if the step two or more standard deviations, then it is a false null hypothesis. But less than two standard deviations, the null hypothesis is true. And
So
because
this
our
is-
numbers is 0.9, well, that's a few score. It's 0.368. That's not even one standard deviation. So the hypothesis is true. So we fail to reject that.
Right, but
No,
0.3
Yeah.
so our standard, you're saying at 0.38 away from 40
From the mean.
from the mean?
Yeah. P-value is. What is the p-value? It's the area away from the mean.
Yeah.
Yeah, that's what p-value
So,
is.
okay, so the mean is 150, so it is the 150. So,
Yeah. Yeah.
so the standard deviation is 40, so 40 away from 50 on both sides. Yeah, 36 is way out there. Is that what we're saying? Am I understanding that right?
Well.
So let's say if answer for question 16, if it was like 2.1, then we would reject the null hypothesis.
Let me share my screen with you real quick, and I might be able to shine some light on it.
Okay.
If I understand it. I don't know if I do. Screen share, desktop. Okay, and yes. Okay, so here we are. So here is the normal probability applet right here. And
Right.
I put in the z-score. And so once you put that in, you get the p-value. This is the p-value, right, that you found?
Right.
So in the book, let me see if I can find the book here. There it is. So this is the section in the book that I was looking at. And basically it says right here, if you have a large p-value, meaning there's a lot of area that is
Oh, gotcha.
that shows, you know, like this blue represents that p-value, I suppose, then you fail to reject it. So if this is really large, you'll fail to reject the null. But if you have a small p-value, meaning that your z-score is way out here, then you would reject it.
Okay.
Yeah, I don't know where the cutoff is, but I figured the probability applet, it looked pretty, you know.
Okay. So fail to reject.
Yeah.
Perfect.
Okay. So are we good with that, Alan? Is that good? Let me see if I can.
Question 18.
Yeah. Yeah.
What is your conclusion for this problem? And I put, we have insufficient evidence that the true population mean is 150. Oh, wait.
So A?
Is that what you put down? You put down A?
I misread these things. Hold on one second. True population. Let me see. Hold on. I'm kind of putting it together right now.
Yeah, I put down C, but that doesn't mean anything because I think I zoomed through this one.
So we have insufficient evidence that the true population is less than 50.
So we know that, so it failed to reject the null hypothesis, therefore
It's true.
it's true.
Yeah,
Uh-huh.
yeah.
It's true, but that means that the mean is true. So wouldn't that be A?
We have
Insufficient evidence that the true.
true.
We have
Isn't it
10.
B? I was thinking it's B. Because it's true.
Oh, goodness, I don't know. Um,
Because the null hypothesis was saying that the mean is 150. So we found out from plotting on the applet that it was true, that the mean was 150. So when we say we have sufficient, insufficient. I wanted to say sufficient. I misread that. So we have sufficient evidence that the true population mean is 150. So wouldn't it be B?
Yes.
No,
That would work. I think so. What I put down was C. I said that we have insufficient evidence that the true population mean is less than 150. And the reason why I put that one down is it's kind of like it's like the same thing, but not, because we have insufficient evidence that, I mean, it's basically like the opposite side of having sufficient evidence that the true population mean is 150. I don't know if that makes sense.
But didn't we prove that the null hypothesis was true? And the null hypothesis says that the mean is 150.
We did. So I'm trying to figure out why I put that down.
But that was also one I hadn't marked. I just wanted to wait to see the other answers I didn't have to make that decision.
So I think the reason why I put that down was because the test was to find out if the average has decreased. So the test wasn't to find out if the mean was still 150. It was to find out if the mean was less than 150.
Okay, so when the story manager suspects that the average has decreased.
Mm-hmm.
Okay, I can see what you're saying.
I feel like it goes either way. Did you guys both put B? Because if you both put B, I'm going to go ahead and put B as well, because I think it could go.
I hadn't marked it because I didn't know the answer to the one above.
Oh, I see.
I think it's B, but I see your point, Dakota.
Gotcha. Yeah, let's go ahead and put B, and let's see what happens.
Okay.
I'm going to mark 18 and just say that I put down C, and we can go back to it if need be.
Okay.
Okay, so question 19 then. There's two types of errors that can be made. I put down type 2.
It's type 1.
I put type 1 as well, too.
Ooh, well.
So type 1 is when you reject the truth.
Type 1 is when you reject the true claim.
So let's say you find a cure for cancer, but you reject it, you make a type 1 error.
Okay.
But when you don't find the cure, but you don't reject it, then you find, then you have a type 2 error.
Gotcha.
So the book says a type 1 error is committed when we reject a true null hypothesis. Another problem that can arise is to fail to reject a false null hypothesis. So it says we do not want to commit type 1 errors, so why not choose a very small value of alpha?
Mm.
So if we choose a small alpha to be small, that we are rarely to commit a type 1 error, what would happen to be the probability of committing a type 2 error? So if you have a smaller a, then you're less likely.
Gotcha. Okay. Well, I went ahead and switched it to type 1 then.
But we'll see.
We'll see.
We'll see.
Question 20, I put down his experiment will be more scientifically valid.
This one, what did Alan say? This one I thought it was more type 1, type 2 error. Because it was like what I read before, if you decrease your alpha, your error type 1 will be less to happen and you're more likely to commit a 2.
Mm. What did you get, Alan? What did you put down?
I put D2.
You put D down?
Okay. Let's do it.
Well, we'll put down D, and if we need to change it, we'll change it.
Which one do you say, Stephanie?
Well, I said B because when I was reading the book, it says if the A value, the probability of committing a type 1 error is very small, that would be decreasing it. The probability of committing a type 2 error would be large. So he took his alpha and decreased it, so he would be less likely to commit a 1 and more likely to commit a 2. Which, what that means, I don't know.
Okay, yeah.
I see what you're saying. So you put down B then?
That's why I put B,
Okay.
but I don't know for sure.
Well, maybe then. I think my struggle is I'm having a hard time understanding the difference between type 1s and type 2s, and I just need to look at it a little bit more.
I think I just need to focus after I get done with this quiz through the weekend and understand it better.
Did we want to change it to B or put it to D?
Well, let's try D.
Try D?
Yeah, because you both said D. Let's just do that and move forward, and then we can always change it to B next.
Okay. Yeah, go ahead and kind of mark it and make sure you know what you put down.
Gotcha.
Okay. For question.
I didn't do 21, to be honest. That was the only one I didn't really do.
Okay. What did you put down, Alan?
I didn't know that one either.
This one,
Give it the alpha.
it seemed like it was too simple. I put down 0.05, but I am probably doing it wrong. So alpha equals 0.05, compute the probability of committing a type 1 error. So what I saw in the book was if the p-value, no, not the p-value, the level of significance is at 0.05, that means you have a 1 in 20 chance of committing a type 1 error. And so 1 in 20 is 0.05. So I feel like it's just like right there. It just gave it to us. I don't know.
Yeah, I'm reading that part in the book right now.
So, I mean, we can see, and it says round to 2 decimal places, and it's only giving us 2 decimal places right there. So if that's not it, then I don't know what it is.
Yeah, I don't know either. That's why I didn't answer. I'm like, ugh.
Yeah. Okay.
All right, let's try it.
Alrighty.
I can try it because I feel like it have a lot of mistakes.
Okay.
I
Yeah.
can change it. Okay.
Okay, I did mine on paper because I was late logging in, so I haven't actually inputted my answers yet.
Oh, okay.
So let me go there.
So we're doing good. That's 16.
What's that?
16 is wrong.
16 is wrong. Is that the only one that's wrong?
18.
18 is wrong.
So 18, we tried E, and we thought it was C too.
Wait, so 18 is wrong and 16 is wrong.
And there were the other ones.
All the other ones were right?
Yeah.
Oh, wow. So just 2
Oh,
wrong.
we did pretty good.
That is pretty good. That's better than
Okay,
I thought.
Yeah, so on 18, are we going to change to C?
Yeah, let's try it because that's what I put down initially.
Okay,
And then let's try 16.
Yeah.
so 16, that's the applet.
16 is the
So maybe our
applet.
negative 0.90 is not right.
3, 6. What did you put down for that, Alan? Did you put down 0.368 for question
16.
16?
Yeah.
Oh,
You did, and that one's wrong then, huh?
But that doesn't make sense because 15's right.
Yeah, 15's right. So the p-value associated with the z-score. What did you put down for question? Well, no, I guess that's not going to change anything. The p-value associated with the z-score from the previous question.
Will you just clarify with him what he put down? Because sometimes he moves his decimal points.
Yeah. What did you put down 0.368? 0.368?
Yeah, 0.368.
Oh, yeah, that is so bizarre. Okay, so it says in the information She sets up a hypothesis test. So the average is 150, but she thinks that it's 144. And so 144 would be less than what she initially put down. Would it just be, instead of being both sides, would it be just like
be the left.
the left side maybe? I
We
don't
have
know.
nothing to lose but try, right?
That's right. Yeah, let me put it down. So 0.18. Hang on.
184.
0.184 for the new answer. Let me try that. .184. I guess we'll find out. One of them's still wrong. Wait a second. Question 20 I got wrong.
That's the only one you got wrong?
So question 16 is right, 0.184.
Woohoo!
What did I put down on 19?
So which one did you get wrong?
No, question 20. Question 20.
So 18 was right now.
Yeah, question 20 says his experiment will be more scientifically valid. That one's not correct.
So I think the probability of type 2 error will
Error will
increase.
increase.
That's what we had.
Oh, okay. I think I just didn't change it.
Well, no, we were trying yours first.
Oh, okay.
So did Alan's not mark wrong? 20 on that first time?
I don't know. Let me run through all of them with you. So
Yeah. Do you mind? 'Cause I'm on paper. I should probably let me put them into the computer while we're doing it so I can submit mine.
yeah, go ahead and do that. That'd be good.
Okay, let's see. True, participate, true. Okay, so for 3, what are we saying?
Null hypothesis.
Okay, and for 4?
4 is null hypothesis.
Sorry, I gotta save these. I'm kind of neurotic that way. Okay, so for 5,
Question 5 is C. Yep, the not equal to 10.
and then 6 was A.
Yep.
7 was B as in boy.
Yep.
8 was A.
Yep.
9 was B.
Yep.
10 was C.
Yep.
11 A.
Yep.
12 A.
Yep.
13 central limit theorem.
Yep.
14 is Z.
Yep.
Okay, and then that takes me to 15. 15 is negative 0.900.
Yep.
16 is 0.184.
Yep. Wait, did you say negative or just 0.184?
Just 0.184.
Yeah, that's right.
Okay, and then 17 fell.
Yep.
18, we have sufficient evidence that the true population mean is less than 150 or C.
C. It's C.
Okay, and then 19, type 1,
Yep.
and then 20, we're saying B this time.
Yep.
And then I'm glad we got that 21 right. Way to go, Dakota.
Yeah, that's awesome.
0.05, correct?
Yep. That's it. So
Let me submit.
see if we got them all this time.
Yep, 100.
Awesome. Good job.
Yay, thanks you guys. Is Alan still there? Did he get the answers?
Alan, did you get everything?
I'm getting them.
You're getting them? Okay. Since you're still on the line here, Stephanie, can you relay those answers back to me so I can put them in?
Yep.
Okay,
So
let
do
me,
you want me to start from the beginning?
hang on, let me get back into it real quick. Hang on.
No problem.
Oh, why this thing does this sometimes. There we go. Okay, so question 3.
Is A,
Okay. Question 4.
is null.
You just saying round 2, Dakota?
Yeah, question 4 is null. Question 5, is that not equal to 10?
Charlie, yes, Charlie, yes, C.
Okay. Question 6
A,
is A. Question 7
B is in boy.
is B. Question 8 is A.
9 is B.
9 is B.
10 is C.
10 is C.
11 is A.
11 is A.
12 is A.
12 is A.
13 is central limit theorem.
13 is central limit theorem.
14 is Z, as in zebra.
14 is Z.
15 is negative 0.900.
Hang on. 15 is negative 0.900.
16 is 0.184.
16 is 0.184.
17 is fail.
17 is fail.
And 18 is C as in Charlie.
18 is C.
19 is type 1.
19 is type 1.
20 is B as in boy.
20 is B.
And 21 is 0.05.
21 is 0.05. Okay. Let's go ahead and submit that. And 100. Awesome.
And does Alan want to do his? Is he okay?
So, I got him.
You got him, Alan?
Yeah.
Awesome. Okay. Yep, you got him.
All right, you guys.
Well, we did it.
Okay, send good mojo this way. I'm taking my test here in about 20 minutes to half hour.
You
So,
betcha. Sounds
Okay.
good. Well, good luck, Stephanie. Thanks so much.
no problem. I'll see you guys all on
Good
Tuesday.
luck, Stephanie.
Okay. See you Tuesday.
Good night.
Good night.
Bye.